Hello everyone, welcome to Miss Charlotte Report, and today we'll be starting off with the weather. Starting off the weather report, in LA it would be 72 degrees Fahrenheit, and if you go to Dallas, you might encounter some heavy rainfall, and it's going to be 52 degrees Fahrenheit, and in Seattle it's 49. Just wait a minute, I'm hearing some new report right now. Getting some information in which a student in Jordan is not able to finish their homework. Zaid will tell us more about this tragic event.
Alright, thank you Nofel from Washington Charlotte News. Today, live coverage from Madaba. We have Abdullah, a student who is struggling to apply transformations in his pre-calc homework. We're going to learn more about this incident and how we're going to help him overcome the issue. Abdullah, may you please tell us what's troubling you?
I'm struggling in applying transformations.
Alright, no worries. We're going to have Professor Francis today helping Abdullah with his homework. Hopefully we can resolve the situation. We have with us Professor Francis. Can you please introduce yourself?
Hi, I'm honored to be in Miss Charlotte's post, and my name is Francis Ayad. I'm a professor in Miss Charlotte's classroom, and I have a master's degree in applied math.
Thank you very much. We'll go back to the classroom to help Abdullah.
Today's class is how to apply transformations. So, Abdullah, do you know what a transformation is?
Transformations consist of vertical translation and horizontal translation.
Abdullah, your answer is partially correct, as it consists of other factors, such as horizontal stretch or compression, vertical stretch or compression, and deflections over the x and y axis. So let's start with an example over here. We have f of x equals ax minus h squared plus k. As you can see, this is an example, which is a quadratic function. This reflects this quadratic function over here, which is graphed, and it has a parabolic shape. So now let's start with the first a value, which shows a vertical shift or compression. And this second a value over here is also another constant term, which shows a horizontal shift or compression, and it's also a reciprocal. And now let's start with this h value over here. So if h is positive, you move to the right. If h is negative, you move to the left. And this is all in the horizontal axis. Now let's start with another constant term over here, which is k. The k over here shows the vertical shift. If it's positive k, it goes a couple of units up. If it's negative k, it goes k units down.
Professor Francis, what about reflection over x and y axis?
Adding on to the k value, so you can have a reflection on the x-axis if you have a negative sign over here, thus making all the x values negative. And you also can have a reflection on the y-axis if your whole function is negative, as seen over here. Now let's start drawing this function over here before going to this function. So we can see that the first function we have is a parent function with the vertex over here on the point 0, 0, which is the origin. Now let's start with the first transformation we could see, which is a negative over here. This negative shows a reflection over the y-axis. So now let's start drawing the first part over here. And at the same time, we also have a origin at 0, 0, which is a vertex of the function. Now we can find over here that there's the h value, which is equal to 2, and the k value is equal to 5. So we're gonna move 2 units to the right and 5 units up. So now let's go step by step and start tackling the h value over here. So now let's start talking about the h value over here. And as you can see, it's positive, so it's gonna move 2 units to the right. So now let's start drawing the function. So we know it's gonna move 2 units to the right, and nothing's going to happen to the y-axis till now. So this is how the function is. we're just going to move it 2 units to the right as I said before. So the coordinate is going to be 2, 0. That's where the vertex is. Now let's talk about the k value over here, which is positive. So it's going to go up 5 units to the 5 units up. So let's start with the final fourth transformation. So we know it's there's 2, and now we're just adding a 5 in the y-axis. So the vertex is going to be over here, and as you know, it's concave down. So we do this, and this is our function.
Thank you very much, Professor. I understand now.
All right, thank you, Professor Francis. Back to Novel at Washington.